Hello, today I'd like to show you my prototype circuit which detects the intensity of light. I will quickly show you a demonstration. If I turn on a voltage source, you can see that some lights have turned on. Now these lights turn on an indication to how bright a light is being detected by the photoresistor right here. If you notice, as a darker shadow comes over it, the lights will change, and in complete darkness, all lights will be off. But as the light continues to get brighter and brighter, more and more lights will turn on. And the last light will turn on when it has achieved maximum brightness, and I have tuned it so that it will turn on only if I get my lamp right up close to the photoresistor. You can see that it only turns on when it has achieved a brightness level with my lamp super close to the resistor, the photoresistor. As you can see, to show you that wasn't a fluke, the darker it gets, more lights turn off, lighter it gets, more lights turn on. You can see it varies with darkness. A neat feature that I have put into my circuit design is that I can adjust the sensitivity of the light being sensed. If I change the potentiometer here and change its resistances, if I make this potentiometer more resistive to electricity, you can see that the sensitivity to light increases. So it takes a less bright light to turn on all lights. But if I decrease the resistance on this potentiometer, you will see that it gets less sensitive and requires more light to turn on the lights. You can see here that in the brightness of my room, if I keep turning it, I can get it tuned to be turned off even in the brightness of my room. So in this case, it would take a very bright light to turn on all four lights. The way you can tune my circuit to, let's say, I want the red light at the very end to only turn on when the lamp is shining on the photoresistor. I just have to adjust the potentiometer so that the red light will be turned on only when my lamp is on. So to indicate this, I will continue turning up the resistance of my potentiometer until the red light turns on, and then it should be tuned to the lamp's brightness right there. So now, only all four lights will turn on only if the lamp is on. If I turn off the lamp, you can see that some of the lights have turned, the tuning light has turned off at the very end. So it's not quite bright enough to light up the fourth LED. But if I flip my light back on, you can see that the red LED turns on and it's bright enough. And to show this is still working, as it gets darker, more lights turn off, and in complete darkness, all lights turn off. This circuit works by using four operational amplifiers used as comparators. The potentiometer here controls the voltage at each of the negative terminals of the op amps. So if I increase the resistance, the voltage at the negative terminals of the op amps decrease. But if I decrease the resistance, the voltage at the operational amps increase. Now, the way that a comparator works is that if the positive terminal of the comparator is greater than the negative terminal, then a output voltage will be supplied. I have it so that the output voltage is 5 volts, and when the positive terminal is not greater than the negative terminal, the output is just ground, so the LEDs will not turn on. Now, the whole bread and butter of the circuit is these circuit dividers right here. This photoresistor is connected to my voltage source and all of these separate resistors. As the room or the area gets more dark, the resistance of this photoresistor will increase, thus decreasing the voltage further down the line of resistors. As the light increases, the photoresistor will become less resistive and have less resistance, thus making each of these voltage dividers have a higher voltage. As we go down the series of resistors, the voltage decreases in each node. However, in between each of these resistors, I have a lead connecting to one of the positive terminals on each of my op amps. These voltages will be the voltages at the positive terminals of the op amp and will be compared to the general negative voltage at the voltage at the negative terminal. If the voltage from my voltage divider is greater than the voltage I have set for all of the op amps for the negative terminal, the light will turn on. But each of these lights will require a higher starting voltage in order to account for the decreasing voltage from this voltage divider. If you want a more visual representation of my circuit, here's my circuit diagram. As you can see, there's all these voltage dividers connected to the positive terminals of the op amps, which are compared to the negative terminal voltage, which is controlled by this potentiometer. Well, I hope you enjoyed my project. It's still a work in progress, but I believe it gets the job done. As you can see, it gets more dark and lights turn off, and the brighter it gets, more lights turn on. Thanks for watching.